Hello, my name is Imed Hammouda from Chalmers and University of Gothenburg. Welcome to the Advanced Software Architecture course. The topic of this lecture is Analysis of Software Architecture. The agenda is as follows. First, we will define what architecture evaluation is. We will then briefly introduce a number of evaluation approaches and discuss the benefits and limits of architecture evaluation. Next, we will discuss in detail a concrete scenario-based evaluation method known as Architecture Trade-off Analysis Method, ATAM. Finally, we will go through an example evaluation exercise of a concrete software system known as SOLA. Before we proceed with the discussion, it is important to note that the terms analysis, assessment, evaluation, and validation will be used in this lecture interchangeably. In this first part of the lecture, we will discuss the three first points related to characterizing architecture evaluation. ITAM will be introduced in the second part. In previous lectures, we have seen that the role of a software architect is quite pivotal in software development. It involves tasks such as articulating the architectural vision, formulating and conceptualizing design solutions, experimenting with alternative solutions, and creating appropriate models. One central task that is often overlooked is the evaluation of architectural solutions. But what is meant by software architecture evaluation? Architecture evaluation can be defined as the process of determining how well the design at hand or a part of it satisfies the requirements derived during the analysis phase of the project. Two central questions are addressed when evaluating an existing software architecture. First, how can we be sure whether the selected architectural solution is the right one? Second, how can we be sure that the selected architecture won't lead to calamity, but instead will guarantee a smooth development process and eventually a successful software product? Now, what exactly to evaluate in software architecture? Which requirements are most important to consider in the evaluation exercise? Let's first revisit two widely used definitions of software architecture. As you can see, both definitions stress the fact that software architecture is about the fundamental externally visible properties of components and connectors. We have also seen that among these properties, architects pay more attention to quality attributes of architectural choices, and that the selected architecture for a given software system is critical in allowing or impeding most, if not all, quality attributes. Now it becomes obvious that architecture evaluation should be carried out taking into consideration most importantly quality properties. We are talking here about quality attribute-driven architecture evaluation. This observation is in line with existing literature on software architecture evaluation. For instance, Clemens, Kassmann, and Klein argue that the evaluator is able to conclude that a quality goal is sensitive to certain properties of the architecture. They also observe that the quality assessment exercise should be made explicit and recorded for future reference and use. Now we come to the question how to evaluate software architecture. What approaches can be used? The first approach is scenario-based evaluation. In this approach, a concrete scenario is considered in the assessment process. For example, we may assess the architecture against a concrete change scenario in order to evaluate the maintainability properties of the system at hand. For instance, a developer may want to make changes to the user interface of the system. Once the change is made and the system is tested, we can collect data about the time it requires to make the desired changes. This data is then used to check to what extent the maintainability requirements of the system are met. The second approach is simulation, where part of the software architecture is implemented at a high level of abstraction and executed in a simulated context. Simulation is useful for evaluating functional requirements too, but particularly helpful for evaluating operational quality attributes such as performance. Prototyping is a form of simulation where a part of the architecture is implemented and executed in the actual system context. In agile methods, architectural spikes can be considered as a form of simulation to reduce the risks and increase confidence in specific design solutions before committing to them. The third approach is mathematical modeling, where mathematical models are used to statically evaluate architectural design models. For example, estimating the computational requirements of execution sequences or checking for potential deadlocks. A related formal approach is the use of architecture description languages, ADLs, to model and quantitatively assess quality properties such as safety and performance. The fourth approach is experience-based assessment. This approach is based on subjective factors like intuition and expertise of software architects. This approach might be the basis for the other evaluation approaches. For example, experienced software architects use their knowledge of architectural patterns and anti-patterns to anticipate the impact of architectural decisions. The next question is, who should carry out architecture evaluation and who should be involved? The most straightforward scenario is that the evaluation is carried out by the software architect herself. This is typically done every time a key design decision is taken or every time a design milestone is achieved. For instance, at the end of every sprint or iteration. The main advantage here is that the architect is familiar to the business case and the system, so the overhead associated with understanding the architecture is minimal. The limitation, however, is that there could be a major personal bias towards the decision taken. Also, the architect perspective might be overly dominant. The second possible evaluation scenario is that the evaluation is carried out by the peers of the architect. This could include other software architects or other members of the development team, including analysts, designers, developers, testers, and maintainers. It is also possible to include members of other development teams within the same organization. The main advantage here is again familiarity with the system and the organization. Another advantage is that more perspectives are considered in the evaluation process, which could help in detecting more shortcomings and in proposing more suitable remedial solutions. The limitation, however, is that there could be a major organizational bias as all the evaluators are affiliated with the same development team or the same organization. The second limitation might be the limited availability of peer evaluators if the evaluation process is not carefully planned. Limited availability might mean that the evaluation process is not taken seriously. A third attractive approach is to involve external experts. Once the architecture is completed, a group of experts is called to a formal evaluation meeting where other project stakeholders are also present. Typically, the architect needs to discuss and defend the architectural decisions and choices in the presence of the experts. The evaluation exercise is ended with a set of recommendations by the experts that the decision makers may or may not consider. The main advantage of this approach is that there is minimal personal and organizational bias. The second advantage is that the evaluation is carefully planned, well executed, and taken seriously. This often leads to valuable expert recommendations. The main limitation, however, is that the system internal details may be exposed to external people, which might be a sensitive issue in highly competitive markets. The second main limitation is that the evaluation is often expensive in terms of travel and salary compensations to the experts, as well as the overhead associated with planning sessions and formal meetings. Our next question is when to carry out the evaluation. There are three possible scenarios to when the evaluation takes place. The first scenario is to examine architectural decisions that are already made and to choose among architectural design options that are still pending. The system is not implemented yet. This is known as early evaluation. The waterfall model of software development is a typical life cycle model where early evaluation is carried out immediately after the design and architecture phase. The second evaluation scenario related to the timing of the evaluation exercise is known as late evaluation. This is the case where the implementation is complete, for instance when using a legacy system as part of the solution to be designed and developed. Another common setting for late evaluation is when open source packages are used. The architects need to evaluate the impact of using those packages on the overall system properties. The third evaluation scenario from timing perspective is continuous evaluation, where assessment is carried out at each development iteration. This is typical in agile methods where an initial just enough architecture is envisioned and developed first by the architect and communicated to the rest of project stakeholders. The architecture is then assessed and updated after each iteration based on the feedback received and collected from stakeholders and developers. Now we come to the question of what are the perceived results and gained benefits of software architecture evaluation. As we said earlier, the main goal of the evaluation exercise is to find out and measure the suitability of the architecture at hand for the system to be developed. However, a common evaluation case takes place when the architect is asked to choose between two or more competing architectures. This is often the case where the architectural solutions are proposed by external consultants. Of course, it is possible that the architect carries out and presents evaluation results of own alternative solutions to project stakeholders. This helps in understanding the pros and cons of each solution. Deciding between alternative architectural designs is primarily taken against system quality goals, of course, system functional features, other design constraints. The available resources at hand should as well be considered in the decision process. Let's stress the fact that in most cases, we are not interested in evaluation results such as yes or no, good or bad, or scalar values. The purpose of the evaluation is rather to find out the important indications of system bottlenecks and hotspots that might occur with the current architectural decisions. There are as well many side important benefits of architecture evaluation. Architecture evaluation sessions represent one of the few occasions where most project stakeholders are put in the same room to discuss the project. This is an important parameter for the success of the project. Second, the evaluation process forces project stakeholders to explicitly articulate the quality goals of the system. This is because the evaluation is carried out against quality properties. This helps in uncovering important quality goals that might have been missed out or overlooked. In case there are conflicting goals, such as security versus performance, the evaluation exercise forces an explicit prioritization of the quality properties. This will help in proposing appropriate architectural decisions that carefully address the identified trade-offs. Similar to the first benefit, architecture evaluation sessions could be one of the rare occasions where the architecture is explicated clearly to all concerned stakeholders. This may facilitate other development tasks such as detailed design, implementation, and testing. A byproduct of architecture evaluation is technical documentation that contains important elements such as quality goals, functional features, system constraints, project resources, architectural decisions and mechanisms, project architectural risks, and trade-offs. Another important benefit that is experienced, particularly when multiple stakeholders are involved in the evaluation session, is the identification of reusable elements that could be incorporated in other projects. This could help to minimize the amount of time, cost, and development effort. Finally, architecture evaluation represents a development best practice that helps in making software development a systematic, disciplined, and quantifiable engineering activity. These qualities often lead to better quality software. Our final question in this part of the lecture is the limits and challenges associated with architecture evaluation. Architecture evaluation is often constrained by a number of contextual factors. First, the extent of the evaluation often depends on the artifacts that are available, including system descriptions, analysis and design models, architectural views, technical documentation of legacy systems, existing implementation, etc. Often, the more artifacts architects can collect, the more extensive and detailed the evaluation is. The second challenge relates to the resources that are allocated to the evaluation exercise. For instance, with limited financial resources, it is unlikely that the evaluation is carried out by external experts. Another important challenge in architecture evaluation relates to who sees the evaluation results. The level of result details might vary depending on whether the results are to be publicly available or privately accessible by specific stakeholders. As pointed out earlier, the evaluation results might vary depending on who is performing the evaluation. The skill level and knowledge of the system are important factors to the evaluation. The evaluation results might also depend on the participants involved. Different stakeholders have their own perspectives to the system, which might influence issues related to priorities and trade-offs. Also, often the development team perspective is quite different from that of the management. Further, the evaluation is often driven by the business goals set. Business goals are the primary source for quality scenarios in scenario-based evaluation approaches. Finally, the use of tools during the evaluation, for instance, automation and documentation tools, might impact the efficiency and duration of the evaluation process. To wrap up, in this part 1, we have defined what architecture evaluation is, discussed a number of approaches to architecture evaluation, and examined the benefits and limits of architecture assessment. In part 2, we will discuss in detail a concrete scenario-based evaluation method known as Architecture Trade-off Analysis Method, ATAM. This was Lecture Analysis of Software Architecture, Part 1. Thank you for watching.